Okay, welcome to this next video on introducing and simplifying ratios. So, much like percentages that we've sort of just had a look at, ratios are a regular part of everyday life. And if you've ever baked, mixed any chemicals or two-stroke motor fuel for maybe whippersnipper or lawnmower, then you've dealt with ratios, okay? Now, ratios are a method of writing a relationship of quantity between two different, or not necessarily two, just between different amounts, okay? And the most important thing that you need to think about is that the quantities need to be in the same units, okay? Very important. For instance, if you need to mix two-stroke motor oil together, it's a 50:1 ratio of fuel to oil, and that means 50 milliliters of fuel for every 1 milliliter of oil. If you didn't use the same units, obviously 50 milliliters of fuel to 1 liter of oil creates a big issue, so you've really got to make sure you're using the same units. Right, a couple of key points we want to talk about ratios. So, first up is the colon symbol is what we use in mathematics to denote a ratio relationship. So it's not just used in writing and things. Colon also has meaning in mathematics, and at the moment this is the only one you need to worry about, is that it's a ratio. Right, ratios, so if we see this ratio here, x colon y, means x to y or x is to y. So that's the two ways that you can sort of say this ratio here, okay? Now, as well as being in the same units, it's very important that the order that ratios are written is very important, and they need to be written in the same units. So, two things here, order is important and same units is important, okay? So x colon y, you can't just flip that around. It has to stay as x colon y. Now, similar to fractions, you can create equivalent ratios. Okay, so that's a key one here, equivalent ratios, by multiplying or dividing all parts by the same amount. Okay, that's something we'll see in this video later on. Essentially, if you get equivalent fractions, you'll get equivalent ratios, no problem. Okay. To simplify ratios, you need to divide all parts by their highest common factor. So again, we don't get rid of our good old friend, the highest common factor. And since ratios should be given in whole numbers, if your ratio has fractions in it, you multiply your fraction ratios by their lowest common denominators to sort of get them into the right ratio. Okay? Right. All right. Create three equivalent ratios for the ratio 4:7. Okay, so here's a quick example. So if we have our 4:7, right, a couple of ways. The way that your textbook suggests that you sort of do your working out for these ratio stuff is just by little arrows to say, now, with that you're going to multiply both of these things by a particular number. Now, remembering with equivalent ratios, it just has to be the same number. It can be any number, so we're going to choose by 3 times by 3, and so 4 times 3 is 12, is to 7 times 3, 21. Okay, so these are equivalent ratios for the ratio 4:7. We could also have 4:7 and go times by 9, times by 9, and end up with 36 is to 63. And finally, 4:7 and go with times by 5, times by 5, and get 20 is to 35. Okay, nothing real surprising there, but that's how we modify our ratios to come out with our equivalent ratios. Sometimes you want different numbers to be able to do different things with, and that's how you do it. Multiply all parts by the same number. Okay, right. Another example is to simplify the ratio 36:9. So 36:9. Now, the key idea here was to think about what is the highest common factor. So the highest common factor of 36 and 9, well, 9 falls to 36, so it is 9. Okay, so the highest common factor of 36 and 9 is 9. Therefore, we simply, as stated before, we divide by 9 and divide by 9. So 36 divided by 9 is 4, and 9 divided by 9 is 1. So 4:1 is the simplified ratio of 36:9. Okay? At the moment, because it's just an abstract example, the numbers may not necessarily mean anything, but this is sort of just showing the process of how to simplify these ratios, because similar to fractions, ideally you are presenting your ratios in their simplified form. Okay, another one here. Example, simplify the ratio 4/5 is to 2/3. Right. So 4/5 is to 2/3. Now, so we have to look at our denominators here, 5 and 3, and think to ourselves, well, what's the lowest common denominator going to be? Well, 5 times 3, they're both prime numbers, so just go with it. And so the lowest common multiple of 5 and 3 is 5 times 3 is 15, and therefore our equivalent ratios are going to be 4/5 times 3, and we have to times the top by 3 as well, and 2/3 times 5 times the top by 5 as well, and we're going to end up with 12/15 is to 10/15. Okay, now once we're looking at this, this is 12/15 is to 10/15. So that's the same thing as saying 12 of whatever units is to 10. Okay, so see how we've just sort of dropped our denominators there? That might seem a little weird, but that's how we roll with our ratios, is that just means 12 of something is to 10 of something. It could be milliliters, could be liters, could be trucks, could be oranges, right? Doesn't really matter. We can just drop that denominator, right, if they're the same. Now, finally, this is should be expressed in its simplest form. So 12 is to 10, both divisible by 2. So we have 6 is to 5. Okay? Right. Finally, an example that sort of involves, say, kind of real-world situation, if you're really weird about your M&Ms. David, who's obviously crazy, has 45 M&Ms and he's counted that 9 of them are red. You need to write the ratio of red M&Ms to the total number of M&Ms. Okay, and then finally write the ratio of red M&Ms to non-red M&Ms. So part A, so we have to do here, the ratio of red is to total. Okay, so red M&Ms, there were 9. The total number of M&Ms, 45. Okay, now this is not our simplified form yet, because both of these have the highest common factor of 9. So we're going to divide by 9, and we're going to end up with 1 is to 5. Okay, so that's our total of red to the total number of M&Ms, 1 is to 5. Alright, now we also needed to look at the ratio of red to non-red. Okay, so doing our ratio of red to non-red, our number of red was 9, and our non-red was 45 minus 9. And then we get 9 is to 45 minus 9 is 36. 9 is to 36. As we sort of saw earlier, that can be simplified to 1 is to 4. Okay, now if you're totally awesome at this stuff, you don't need to actually kind of have these arrows necessarily. You sort of need to think of some way to present it. So I'm quite happy for you to go sort of 9 is to 36, and then like an arrow to say that this can go to 1:4, something like that, or the arrows going down this way, whichever way works for you, and you're able to understand it, and you can communicate, more importantly to me, what sort of is going on, then just go with whatever. Okay, I hope you enjoyed the video. Please come to class with any issues or any questions that you have about the content here. Essentially, it's reasonably easy, and your experience so far in fractions and percentages will really set you up well for ratios. Okay, thanks for watching.